So, continue our discussion about different data structures in Python with respect to containers. We'll talk now a little about sets, in which set is an unordered collection of distinct elements. So there are no equal elements within a set. It's a data structure similar to a list in a dictionary in a way, if you want to use that analogy. But in any case, let's talk about and see how they look like. In this case right here, set is similar to a dictionary because we also have a way of declaring it in a special way. So instead of using dict here, we use set. Also, we can transform a list in a set. So we can say something like set from list, and then let's take a list right here and let's transform this list here into a set. As we talked about it, since a set it's an unordered list without repetition, if we print it out now, this set that we just created, you see that all the elements that we had there that are repeated there, they are gone. So one here, we had 1 and 1, now we just have 1 disappearing here for us. Okay, there's also another way for us to design a set. In this case here, we are putting all the elements explicitly, and this here is also a set. So if you go there and print it out, the type of this, so we can check it out. This is a set of basket, and if you want to print it out the elements, we can just see that the repetitive elements are not there anymore, right? So as we saw, the first thing is a set, and then we see that apple, I'd have to happen twice, is not there anymore. We can do some basic operations with sets the same way we did it with lists and dictionary. You can verify if, for example, does orange is inside our set, as our basket. Nope, in this case here we don't have orange because I put a typo, sorry. In this case here now we can see that this is there, so we have orange inside our basket, so that's fine. Also, you can add some elements inside our set. It's a mutable object, so we can simply populate it with more items, right? So let's say I want to have, we can take our set here of a basket and we want to add something as in kiwi like this. And then we go there and print the elements inside our basket to see what happened. We see that there is a new element right there, and it doesn't follow any necessarily order, right? The thing is, if you add an element which already exists in that set, and we can simply go there and print it out the elements for us to take a look on this again. We'll see that it didn't, oops, I had a typo, sorry for that, apple. Let's consider this element. We were able to add this because I made a typo here, but we add apple, we'll see that since the element already exists there, it doesn't affect the content of our list, right? And the same way we can add, if you want, you can just call the same way in doing a remove, so you would remove the element that you have there. So let's show how it would look. Let's try to remove the typo that we had there, right? So if we run that again, we'll see that the element that we previously put it there is not there anymore. We can also do some interesting operations with our sets, such as a set algebra like union, set operations and union, intersection, so on and so forth. Since this is a non-repetitive item list, you can also iterate over it using a for, but let's not just go there. It's the same thing as a list, so you wouldn't change anything, right? One thing that's pretty cool is, let's say we have a string and we want to transform that string into a set just to get rid of all the elements that we have there. So if we have a string like Mississippi here, and we go there and we print that, now that's this list. This is pretty much as a list of characters, right? So if we put and force a set into that list, we'll see that just the non-repetitive elements, they were there for us, right? The same way in a list, if you try to access an element which does not exist, or in a dictionary, something similar happens if you try to access, or for example, if you try to remove an element that it does not exist in our set. So for example, in this case right here, there is no key, or there is no letter Z in our set that we just talked, so it's not possible to access. Then there are some other ways for us to work around this. So in case, like for example, we tried to do user remove and it didn't work out, right? So we got an error. There is another way. We can just go there and discard the element. In that case, if the element does not exist in our set, nothing happens. So it's kind of a safe way to do a remove in a smart way. We can also do a pop, as we did it before with our list. And then let's print it out to see what happened with that list of us. And as we saw, the last element inside there, that was, the first element here, it got removed. Or or we can just wipe out all the elements at once. So if we do something as A and clear, and we go there and let's print the whatever list we have there, and we'll see that since we use the clear, we wiped out all the elements inside that set. If we try to print, the result is our empty set that we tried, right? Also, as I said, we can do some operations. For example, let's say that we have the words. Let's add some cells here before we run out of space. Let's say we have the cell here that and transform as a set, so we can work with this a little bit better. Let's say we have abracadabra. And then we have another set, and here we have alakazam. And we'll do some operations with this. For example, if we want to do, let's first define those two guys here, right? And then we'll do A minus B. Well, you know, before we do the operations, it's quite hard to see all the repetitive letters here, so why not print it out A, and then we print it out B, right? So we have those two there, and if we do an intersection, a difference right here, we'll get all the elements that are in A but are not in B, and of course we have to print it out this. Sorry for that. And we'll see that all the elements that are in A that are not in B, we have R, and we have a D, and we have a B. All the others, they kind of overlap between them. All right, and then of course the difference in set operations, they are different. So if you change the order, you will get a different result, right? So if we do print, and then we'll print it out C here, we'll see that we have a different result because now I have all the elements that are in B but are not in A. The intersection, it's a little bit different. So let's do it. Let's do a print directly. So if we do A and B like this, It's just the elements that are in both of them at the same time, in which in this case here it's A and C here and A and C here, right? We also have symmetric difference, union, and so on and so forth. Basically, each and every operation you can do in the set operations you can do here using the sets that we just described. All right, so in this case here we do the union, so both of them, and since A and C then happen to appear in both of them, we'll just see them once in our final structure. Okay? Needless to say, the same way we did dictionary comprehensions and tuple comprehensions, list comprehensions, you can also do the same thing for set if you want it. Okay? So thank you and happy coding!